All right, welcome to the final day. Woohoo! We made it. Barely. Well, we are here to talk about SDN and Skype for Business and how we got some really cool stuff to work just this morning. So, yippee, we made it. My name is Christian Burke from Microsoft. I'm a Technology Solutions Professional, TSP, aka, in Southern California. I also have David Tucker from Event Zero, the CEO, and also Michael Butler from Nectar. Michael Butler from Nectar, Senior Director. And we got some really exciting stuff to show you guys today. Oh, let's switch over. Pause. You're 7. Anybody know what that is?
A number.
You don't get a shirt for that. Anyone else? Want to hazard a guess? Yeah, who said that first? That was right over there. Did I make it? Does anyone know what's special about this one?
It sucks.
It's horrible, yes. That's not special. It's live. It's coming out of the new Skype for Business client. We're getting real mid-call data in flight right now. So this is the first time we've done it. And we're stoked. It works. Look, it works. And that's the basis of what we're going to talk about today. There's a lot of really good stuff under the hood. I'm going to keep it kind of high level. I'm going to set the stage for these guys, and then these guys are going to nerd out on you, okay? It's a 300 level session. It may dip into 400, so try and stay awake. But it's pretty cool. So let's talk about it. Real quick. Oh, yeah, sorry. There. We'll do an agenda real quick. I have some time. I'm going to try and humanize this thing for you a little bit. Mike's going to talk about SDN and the Skype for Business model. Dave's going to do the data deep dive and show what they've gotten to work. And then we'll give you a nice little cool demo at the end and plenty of time for Q&A. So I assume most of you are pretty darn tech here. I assume some of you have had the admin link. I'm sure many of you have had that scenario where you got that call saying, we just had a horrible conference. Half the people were frustrated. Tell us what happened. You're flying blind. Totally ill-equipped to do what you need to do to answer the question. We have monitoring servers. We have some other things we do. You got to go into it. 3 days later, you come up with the answer. That call's long gone by then. That experience is still resonating through that executive or whoever had that. And we know there's some third-party tools that can help get it done right now, kind of like Event Zero, kind of like Nectar, that we can get some real-time data out in a conference, but those point-to-point calls we've never been able to do that. So now we've got real-time data. 1 second. Yeah. Now we have real-time data. Now with Skype for Business, we have the opportunity to see calls, see meetings in flight. We can make better decisions in real time. We can do some really cool stuff with it. Imagine what you could do if you add things like automation, machine learning to that data. We'll be able to actually go further and be able to take that call, be able to address it before it even happens. Come on, work. There we go. So I'm about to butcher SDN for a little bit. So just officially, I have on here what SDN is. But I'm actually going to change things up a little bit, because what these guys do with it is kind of not the way SDN was designed to do. But we figured out we can do some really cool stuff. So instead, I'm going to show you my view of it. I'm going to try and simplify it so these guys can go hardcore on it. Okay? So think about putting this together in your lab. I'm sure half of you have labs, probably more. Go out and get yourself an SDN controller, plug it in, and in the traditional model, you get some network switches and routers and so on, and you let those things connect with each other. Cool. Now you can start routing traffic and doing things. That's SDN. We got some ideas of adding link into the mix, so we threw some applications behind it. Developed an SDN API, and we started pumping some data into that SDN controller too, with the intention of being able to maybe reroute calls and do some other manipulation. Some of the struggles we've had with this model and why SDN's taken a while to take root is, well, how much money have you invested in your network switches and routers? So the reality is it's 5 years off, maybe, before you can do something about it, before you've recycled all your switches, all your routers, all the devices, and be able to have them all act. Problem is, I don't think we need to wait to leverage the data. So this is where the SDN purists are going to look at me sideways a little bit. Instead, we drop some data into a database. And what we're doing is taking that SDN controller and rerouting some data into a database. The cool thing is, now we can start plugging stuff into it, and we can start looking at the data and doing things with it. Whether they're applications, putting big boards up, looking at the data, maybe doing some BI up against it, other plugins, apps, things like that. Now we're able to leverage that data that's sitting there and do something significant with it. And we don't have to wait for all of our infrastructure to be changed out. We can do this now. And hey, maybe we can even take that data and plug that back in and start doing some machine learning with it and have these things take that data through automation and so on and put it back in those devices. But first, we just want to see it work. So, I'm not going to be a slide reader, but basically we do now have that ability to visualize and take action on that data through SDN right now. So, when the slide moves, let's try that again. Let's try that again. Let's try that again. Thank you. Okay, good. So, I am not sure if you guys heard some of the announcements this week about the IT Pro Tools program. This is basically the in launching Skype for Business. Of course, there's IP phones and third-party tools, software, hardware, meeting room systems, and things like that. And we also now have this new IT Pro Tools program. And there's 3 key strategic partners, if this thing ever works, thank you, in the game. Happen to have 2 of the 3 here today, and we hope to have the 3rd soon. We have Event Zero. They've already got products and tools on the board that they're already using to leverage this data. Nectar's doing the same thing with some of their tools. And Unify Square is working at that as well. And with that, I am going to turn it over to Mike, who's going to talk about, he's basically going to build this model, what we're doing with SDN, how it integrates with Skype for Business. All right?
Hello, hello,
It
hello.
is yours.
Hello. Hello. So my voice is a little rugged from speaking with 22,000 people, I think, this week. So bear with me, if you will. But I'm really surprised that, congratulations to all of you for surviving and actually making it here. I think our over-under was probably 15 attendees, and it's significantly larger than that. So nice work. So what I'm going to talk about a bit, or I'll just tap this. What I'll talk about, I'll go a little bit more old school and hardcore on what the SDN model is. and how it's evolving, and then I'll talk about Skype for Business, audio quality scenarios using the SDN API, and I'll bring it to life in ways that are real to our IT admins and our managed services providers. So we've actually got the SDN API. It used to be called the SDN API. It's now the SDN interface. We have linked deployments where we have customers that have enabled this, and this is all real. So all of this is not dreams and hopes of what we're doing. Everything I'm showing you is stuff that we have out in the field today that people are benefiting from. So hopefully it'll be useful. So when you look at the SDN framework more collegiately, I guess, you've got the application, you have the controller in the center, that's kind of the brains of the world, that needs to know what's going on. And then you've got your network elements down below. This thing's not working. Tap, please. So when you look at the controller side and above, that's kind of the control plane. So the control plane is going to be defining the requirements that are required for the underlying network. Will you tap it again, please, David? The forwarding plane is the hard work of actually pushing packets forward. Now, don't diminish the value of the forwarding plane. I know that things have happened, like Google's running an SDN network, not only in their data center, but across their entire wide area network. And they've ripped out a bunch of Cisco switches. They've built their own merchant silicon switches, doing a lot of forwarding, but they still have to do a lot of traffic shaping and a lot of work around that. When you look in the enterprise environment, we have a lot of routers, a lot of switches, a lot of complex QoS configurations that we have to work within today. So some of these SDN concepts we're going to show you will enable you to continue to leverage your existing investments, however, to kind of optimize your productivity and capabilities around working within that framework. So fundamentally, what the northbound, there's this concept of a northbound interface and a southbound interface. Southbound interface we'll go to, that's kind of open flow. And northbound interface is something that Pascal Meneses and the Skype for Business team product group is helping to actively define. And what it really means is that applications like Skype for Business know what it needs. Like when you make an audio call, the client knows what its requirements are. It knows what its bandwidth capabilities are, and we'll show you this. You send out SDPs, negotiates codecs. So it's telling something, these are my requirements. However, prior to any SDN, it was telling a back-end server in a monitoring database, these are my requirements, which is kind of great, but doesn't really help you much. Now, so you express your requirements via this northbound interface, and we'll see standardization happening, and probably other communication solutions going in this same direction over time. Now, the controller then does a lot of orchestration work. It'll kind of reformat data, and it'll look at other vectors kind of laterally to see what are the requirements on the underlying network, and then it will fulfill the requirements that it's received from the Skype for Business client. Does this kind of make sense? Have people been going to SDN meetings so far? Raise your hand if you've been in to another SDN session. All right, cool. So I'm just kind of reaffirming what's going on and what you've already learned. Go ahead. So when you look about SDN scenarios, the first thing you need to do to have any opportunity for success in your Skype for Business deployment, which you will have success with it, we've just found that a lot of customers who haven't effectively planned and thought through a UC deployment have been burned pretty badly because the underlying network isn't quite ready for one device to start spitting profiles of audio, video, application sharing. And not only, you think about traditional QoS methodologies and constructs. You have a device that's VLAN separated, subnet separated, has a known codec, it's not rate adaptive, it's going to give a specific profile of traffic, and you police that throughout your network. Skype for Business enables you to do a lot of things differently. And when you think about mobility, it's not just a mobile phone, but now you're going to have people finishing calls while they're walking across the office over to their meeting room. And how the heck do you support that? Well, with the SDN constructs, now that you're getting real-time visibility into what's going on in the network, what Skype is actually trying to do, what your users are trying to do, you can leverage that to manage that experience. So the first piece, you have to be able to monitor what's going on. That is probably That's foundational within SDN. The second scenario that we'll talk through is diagnostics. So if you know what's going on, and if you can become enlightened to other aspects within the network as well, now you can start more effectively diagnosing problems that happen when they occur, or more quickly doing so. So think if you're one of the support engineers, or if you ever had a role as a support engineer. Somebody calls you, they said, wow, I really had a crappy experience this morning when I was on a call. The guy couldn't call you for 4 hours until, after he had the call because he was in back-to-back meetings, gives you a call, says, hey, I had a crappy call. So the voice guy gets it. He says, all right, well, I don't really see anything that went wrong, so it must have been a network thing. Let me open up a trouble ticket with the network group. Network group gets the ticket, they ping the interface, everything's fine, I don't know what you're talking about. Let's try to reproduce it. Then you get on the call, and everything works perfectly. Like miraculously, everything works fine when you try to reproduce it. And these are impossible, and they're death for deployments of UC. Skype for Business being really the only true UC client in the market today. I mean, Jabber gets a little love, but really, we don't see that very much. It's having to break these grounds and do these things. So diagnostics is absolutely critical when you're looking at Skype for Business deployment, because you got to reduce your support costs, you got to make sense of it, and you have to know what's going on in your network. Now lastly is what I like to refer to as the unicorn. The unicorn, which can be interpreted many different ways, but the unicorn is like an elastic, agile, automated solution, which doesn't really exist today. You're talking about collapsing telephony, presence, conferencing, and network teams or tools into something now which is kind of self-learning. Christian was talking about machine learning. When you look at remediation, you're saying, hey, I see that I'm having a problem somewhere in the network, I being the controller or being your system. So I'm getting these requirements from this northbound interface. I know that I'm having additional load. Let me just go fix it. So I've got a quality of service queue configuration, EFQ configuration that's 20% on an interface that's getting hammered. Now, what if you didn't have to go troubleshoot that, but the network knew that it needed additional requirements, went in, made a configuration, your users aren't complaining, you didn't have to do anything. That's the power of SDN. That's where we're going with it. So I'll walk you through a little bit of some different scenarios, and then we'll get into the mechanics of how SDN works for Skype for Business. And if anybody has questions, just go ahead and speak up. If you fall asleep because it's a little slow, just don't snore.
So I got a question.
Yeah.
Talking about making the adjustment for the EFQs on the provider side. So that's, locked down.
That's a heck of a good question. Yeah, the question was, what if the problem is on the service provider side? So maybe who has not deployed voice over IP in your environment? Who still has a traditional telephony system? It's awesome. So maybe you haven't confronted this problem yet. But typically, when you deploy VoIP, you then deploy an MPLS network from your provider or something, and then you apply a quality of service configuration on your interfaces on each of the ports, and the provider says, you go ahead and define what your queues are going to be. So to your point, you say, I want a 20% EFQ on my data center link. And then what if you start having problems and overrunning it? SDN is not in a spot to address the kind of multi-domain, multi-autonomy problem. So especially when you start looking at the complexities of Office 365 and voice, a very likely scenario is you're going to have Office 365 in their own domain from a compliance, regulatory, security management tool standpoint. Now you've got a service delivery platform, which is your wide area network, be it MPLS, be it internet. And now you've got a third domain, which is that customer domain. Different compliance, different regulatory, different rules. If you know what's going on in your network in real time, if you can correlate it to times and events, think of the power of you calling your service provider and saying, hey, you know what? I was having problems between 8 and 9:30 Thursday morning out of this site with my voice quality, will you pull logs off of the interface and look at what my queues were doing? Granted, that's not automation, but it's a heck of a better conversation than you can have today with them, right? But great question. You see the bigger problem that needs to be solved with this. So when we look through these scenarios, then we've got modality adoption. Like Event Zero does some absolutely fantastic dashboards, and they show great modality adoption. So they're looking at this beyond just voice and video, because SDN isn't just about your real-time traffic. Again, it's about the entire user experience you're managing. You can see usage more effectively. You can then you can really manage that user experience with Skype for Business. So the diagnostic scenarios, that's where we're trying to find why. I've talked through this a bit. If you know that there's a call and you have visibility to the underlying network and you're implementing or deploying systems which can effectively leverage that data in more real time, now you can diagnose things without having to have a lot of human intervention in that. So take tier 1, tier 2 troubleshooting, which is log review, which I don't care who you are, that's not fun. I mean, maybe it's fun. Maybe, who likes looking through, you know, gigs of logs trying to identify a timestamp for a problem on an interface? Wow.
I'm with you.
Yeah. All right. I might need your card. I don't like that. There's a lot of better things to do, but maybe not. All right. It's funny. For each of the one-offs, we've had just one person so far. Well, two. All right. So we're growing. We're growing. And then remediation scenarios. I talked a bit about this. This is the unicorn, but these things are actually in market today. Wi-Fi is a problem. Horrible spectrum. You know, it's very, very, very challenging to deploy correctly. Some people put SSIDs up for everything. They don't realize that's like having, you know, you keep diminishing your bandwidth and throughput capabilities. But so the Wi-Fi vendors have really glommed onto the Skype for Business SDN API, because they're like, hey, at least tell me when things are happening, and then let me better manage that air and that media that we're transiting on to make it a better user experience. Dynamic QoS, again, we're talking about this. Not at the service provider space yet, but you can do this within your network. And adaptive traffic engineering, there are solutions out there in the market, like HP and some others, who are doing some really cool things where you can tell them, I've got these traffic requirements, and now they're making flow forwarding decisions in real time in your network. So if you guys were at the SDN panel, you also saw Sonus was talking about doing that as well. So things are starting to happen. It's starting to become a little more elastic, and we're starting to get into the wide area network space. All of this that we're talking about today from a northbound interface is starting to become termed UC SDN or WAN SDN, some people refer to it as, because SDN grew up out of the data center. But things are starting to materialize here. So it's good you guys are here talking about it. Thank you, sir. All right, so let's walk through the mechanics of the SDN interface for Skype for Business. So obviously, there are not a lot of components here. I'm just trying to isolate it down to the relevant components. So if you guys were looking for super detailed topology diagrams, I apologize. Will you tap it, please? So the first thing you have is on the front ends, you'll have sorry. You'll have a link dialog listener. It's an MSPL app that you just load on. Utilization is not bad. We've got it in some, you know, pretty significant size deployments. You're looking at maybe 1% CPU utilization hit at 15,000 concurrent sessions, right? So it's nothing to worry about. The other component is Link SDN Manager. These I don't know when they'll change them to Skype for Business Manager. But what that component then is taking the messages. So the link dialog listener, if any of you guys have worked with MSPL scripts before, we call those SIP collectors. That's how we refer to them. People tend to understand that a little bit better. So then the SIP collector is going to look at sessions. It's going to forward them out to the LSM pool. The LSM pool is going to kind of scrub it, clean it a little bit, and then forward that out to the last component you need for an SDN solution today, which is, we tap it, a controller. And all the controllers are third-party controllers that you're seeing today. They come in many various forms and with different features and functionality. But that's the additional components to your existing Skype for Business deployment you'll need, or for the customer that you're deploying for, in order to light up this real-time visibility. So let's walk through a call, being this is SDN for call quality. This is the Skype for Business interface. Go ahead, tap it. So one more time, please. Oh, I have that out of order. One more time. So you guys know the escalation. If you guys are using Link, you see some resource you need to have a conversation with, hop into an IM and talk to them, boom, you escalate it up to an audio call. What does this actually look like from an SDN interface standpoint? Next slide, please. So I really wish I had this. I feel sorry, David, for you having to do this. Go ahead and click, please. So at the to instantiate a session, audio, video call, anything, there's obviously some signaling that has to be established. So at the initiation, I'm going to go call somebody. I am that Link user at top. Other guy is another Link user. The signaling is established. Click it again, please. The SIP collectors identify, hey, this is a real-time media session or a session of interest. It then takes the information from the Skype for Business client, forwards it out to the LSM pool, sends it out to the controller. Go ahead, next slide, please. Now, what the actual message looks like, let me come over and, are these touch screens, or do we have a mouse here? All right, so if you see this, oh boy, whoops, back.
There you go.
So we at Nectar, at least, and I can only speak for myself in this space, we like to take the initial invite message, because what we do is we have a history of managing telephony environments, and we not only want to know when a session is poor, but we also want to know when a session is not established. So with the SDN interface, in real time, you can understand, let's pop to the next slide, please. You can understand, and go ahead and pop one more, that, hey, somebody tried to make a call and the service was unavailable. Now, this can be popped up into dashboards. It can be, we can have PCAPs available for it. One more time. And then you can see that, the reason it wasn't completed is that there was service unavailable. So maybe you've got a problem with capacity on SIP trunks. Maybe you haven't correctly architected your environment. Maybe you did the same deployment model that a lot of customers have done, which is deploy it as IM and presence without much user training. They start finding everything, and you haven't done the rest of the back-end capacity work you needed to. But you know when this happens, either a user can call you and say, I couldn't make a call. You can alert on this, and now you know, like, ooh, we got a trunk capacity issue. It's not something that kind of sits there and stews and burns for a while. Go on, please. So the next piece then is, once you have the signaling established and you've negotiated the codecs, go ahead, next one, then the media is established between the clients. And this can be in a conference scenario, it can be point to point, it can be whatever. So in the Skype for Business terminology or taxonomy, this is the start dialogue that's been established. At the establishment of the start dialogue then, again, you're going to have the LDL send a message off to the LSM, which is going to get forwarded out to controllers. Click, click, and click. And then this is what the message looks like. You've got your to from. Is everybody aware of what all the call messages look like in the QoE database? Are you familiar with all the different information presented in the SDP and messaging? Is somebody not familiar with that? One guy's not familiar with it. Oh, two guys are not familiar with it. So there's an incredibly rich data set available in the QoE database, and a lot of it comes from the client. And so you've got things, and let me see, I don't think this is touch. So 1 second, I don't want to forward it. But you've got your connection. You've got, oh man, I don't know why that's not going to, I'm not going to be able to do that. So I tried to do something cool, and it's just not, so I apologize. But what you're seeing is you've got the to, the from, you've got the codec they negotiated, you've got IP ports, you've got reflexive ports, you've got the UDP ports they're using, you've got the different devices they're on. So you can very quickly surface information. Like, for example, it's a BYOD environment, somebody brings a really old laptop in, they throw a link client on it, and they're having a bunch of poor calls, you'll pick it up right away. Go on. And so when we look at scenarios of how our IT admins are able to use this, you can put up dashboards like, hey, what are these, how many real-time calls do I have going on in my environment? How many people are using the infrastructure today? How many over certain periods of time are using them? And what is that average duration and session length? I mean, you get a lot of analysis that's now presented up to you very easily versus going in and trying to pull reports out of QoE databases. Other things you can see, for example, if you wanted to, you could put up dashboards showing who are in meetings. I think that's the demo that you're going to be showing. You can actively show these people are in a conference right now. I mean, this is really powerful stuff. And depending upon different elements you have within that, you might be able to tell what their quality is during that conference at that time, either through third-party elements or through the Skype for Business in-call updates, as we hope to demonstrate a little bit later. Go on. Oh, sorry about that. And continue forward. Now, the quality update, and this is kind of a bummer I can't show this, but in Link 2013 and 2010, at the end of, and when Skype for Business is out in the Mac clients and iOS clients and Android clients, you're still just going to have an end of call quality update. And that quality update gives you all of your performance data that you need. It has send, listen, MOS, so how was it coming from the ear to the machine, gives you the overall MOS, gives you jitter, packet loss, delay, and you can use this information. Let's go to the next one. To immediately have and gain insight into those user experiences. So for example, this was something I pulled out of an internal meeting we had. You've got what is the max potential MOS and what was the realized MOS. So was that a good call? Who was in it? I think you can click through. Back. Who was in that call? And then in the event that something was bad and maybe you've got a heated user executive who's like, I just had a horrible call, you know. Now, hopefully you've got other elements. You can go diagnose it and do some other things. But this is the power that's enabled through the SDN interface in being able to very effectively manage your end user experience to ensure a high quality user experience and to ensure that you get your stuff rolled out with people not beating you too badly. Yes?
It looks like you're collecting all this information from your SIP collector.
Yes.
Any of the SDN APIs?
Well, the SIP collector is a component of the SDN API, or the SDN interface. The SDN interface from Skype contains the LDLs, which are the SIP collectors on the front ends, and then the Link SDN manager. So yeah, it's all picked up. A client sends the update, goes through the front end, it's mirrored off of that, for lack of a better term, and then forwarded out to the SDN manager. And then there could be solutions where you have other elements which are deriving media values and signaling values as well. So it could be munged from multiple different sources. Does that make sense? Okay. Yep.
Yeah, I'm a little confused too. Like the normal QoE data right now, after the call is done, it goes into the QoE database.
That's right.
Is it different than that?
No. No, it's just presented to you. So there's a time element associated with gathering things out of the QoE database, and there's also an effort element associated with gathering that. We are sourcing the same information. Like if all you do is deploy the SDN interface, then you will get the QoE database information just in a more usable format at a more relevant time. It's on its way to the QoE database. Because the actual flow is client, front end, monitoring server, QoE database. All right. Yes?
Does it also include video and app sharing?
Absolutely.
But here you're focusing on the voice.
Well, SDN for audio call quality, managing audio call quality, I think was the topic of the situation. But really, what I want to hand it over to David Tucker, but I think what you'll notice from, well, no, I don't even think we talk about this in this presentation. But I don't want to speak for Mr. Tucker, but they do a similar, they have an SDN model, and they pick up a lot more than just the real-time media and interaction. And so you can pull up active IM sessions and all kinds of things. So without further ado, Mr. Tucker. Whoa.
Does Microsoft permit you to intercept this data in Office 365, particularly with a dedicated file?
So
We will answer that one afterwards. We'll save that one.
I'll let Christian answer that one afterwards. David?
It's a really good Q&A for after.
Am I on? Hello. Okay, all good. So, I'll just start and apologise for the shirt. I have been in a few sessions this week where the lighting has not been so good as in here. And what I'm sitting at the back seeing is a bobblehead and some arms doing this because everything else is black. And I just thought I'd make sure you could see me. So here I am. So I'm going to go a little bit deeper on some topics. I've been playing with in-call quality now for, since we could do it, which was like 4 or 5 months ago. And I've been very, very deep into this for quite some time. So compatibility, Wave 16, right? So you can't do in-call quality updates from anything but, at the moment, the Wave 16 desktop client when you're making calls using any of the clients, that is. The modern client version, I'm actually not sure exactly what version it is, but there is a version of that also does it. And the mediation server, which is also a surprise to me. And there's a caveat on UCWA, because it does it, but a little bit differently. So I took it off this. And of course you need Skype for Business and SDN 2.1. And the latest version of 2.1 has some extra bits in it as well. So to enable it, basically PowerShell, pretty simple commands. It's a policy, everyone's seen policies. You can set that global site or a service. And the important thing here is the time, the interval. And the interval, for me, was a rabbit hole when I started looking at in-call quality updates as to what should it be set to. The default's around 30 seconds. And 30 seconds, if everyone knows, if you want to go to the next one. 30 seconds is a very long time. A lot can happen in a network in 30 seconds. You can start up a Netflix, you can watch a corporate video, you can lose a router and have it come back in 30 seconds. So the default is something that needs to be looked at very, very closely, and I'm going to dig in a bit on that. So the other way to set it up is to do it in a client. So sometimes, particularly because it's a bit of an unknown at the moment, how much traffic is really generated from in-call quality updates, because there's a lot of variables that come into play, you might only want to do it on a couple of clients. So you can put it into a handful of users and just get that data off a few test cases. So you just got to add the file, restart the client, and good to go. Next. So the algorithms that are used to create MOS scores, and a lot of the information actually, have a weighted influence. And what that means is that now has more influence than before. And the before is really the period of the updates in call quality updates is what we're talking about. I've over-exaggerated it a little bit here. It's, this is for visual purposes more than anything else. But you get more influence on the score in this second than you did 30 seconds ago. So as you adjust things, it makes a big difference. Next. And you can see here an example. So I mean, this is not a real call, I just put some data together. But you can see here if the spike at the end, this is where I need the latest pointer. So the spike, the drop at the end here is going to reflect more in the numbers that you get from in-call quality update than the one right at the start. So you adjust based on those requirements. Next. Next. So this is an example. So, you know, just simple theory, right? We took a time, we cut it in half, and now we get more visibility into that same data. The more you cut it in half, next. The more you cut it in half, the more resolution you get, the more data you generate. So there's good and bad to that. The other thing to keep in mind as well is that in-call quality updates don't mean that you get in-call quality updates. You actually only get them when certain things happen. So there's triggers that come from the clients. So as they're evaluating the quality of the streams going in and out, there's certain elements that say, hey, send an update. In SDN, I think it's in the latest one, you actually get these triggers as well. So you can detect what happened, you know, what made it update. Next. So just looking at a call here over 60 seconds. Next. If you have a default, or sorry, so if you did a 60-second call and you had your time set at 60 seconds, what you get is one message at the end of the call, and you're going to miss a lot of the detail. Next. Next. If you set it at 30 seconds, you're going to get one at 30 seconds. So there's another little trick to this. When a call starts, if you set your interval at, say, 10 seconds, you will always get a message at 10 seconds. So here, in this example, I've set at 30 seconds, so I get a 30-second message, and I get another 30-second message. And if you look at the data, it's because of how it's triggered, right? The trigger that creates the event is outside of the bounds of when we set the intervals. Next. So if we set it at 10 seconds, what we'll see is a completely different profile again. And I'm not making any recommendations here as to what you should set it to. These are just the influences over why you would do this. So just tab through. So at 10 seconds, we would get the initial update. We wouldn't see the second update because there's not a significant change. So I've just used this graph, the data that I've plotted there is just an example, right? So chances are you're not going to get a message at that point because nothing significantly changed. But at the next interval you would, because there's been a change in the profile of the streams. You would get one in the fourth update. You wouldn't get a fifth, and you wouldn't get a sixth, apart from the end of call, right? Because it's still exactly the same. So there's all these little things that come into play you have to take into account when you're setting up the interval. It's strange, it's one number. It's a tiny little number in a policy that you would think just irrelevant. But when you dig in, it's really important. The more data you get, the more data you have to handle. The less data you get, the less visibility you have. So it's an age-old problem in IT. So this is another example here. If you set it 10 seconds over a 1-minute call, again, you get the very first update. You don't see anything else until the end of the call. Next. Yeah?
So if you set the interval to a small interval, you get better granularity.
Yeah.
What is the impact to your network?
More data. So the packets that are being sent are really only 2-3K. They're not massive, But you have 40,000 users and an issue in your network, and all of a sudden you have an issue because it's a lot of data. It's nowhere near the call, obviously. It's a small amount, but
Can you rephrase the question? What's the impact to link server?
very small. It's only another SIP message. There's millions of them flying backwards and forwards all the time. So it doesn't, it will have an impact. It has to be processed. But if you're keeping with the suggested scaling, you're fine. So the influences that I have found during this exercise is really call length, right? We can measure our average call. We know how long a call is. We're pretty good at that. 2.5 minutes is kind of the average if you take out conferencing. If you add conference, it's different again. Quality shift. So this is a really weird one. What I found in our network, and our network is very small, we're only a handful of people, but the amount of change in the network, the amount of change in the bandwidth, the amount of information that's flying backwards and forwards just in the trunks between endpoints have a big influence over this because of those triggers, right? If you have 10 gigabit between two clients and that never changes, you're never really going to get updates. You're going to get good quality and you won't have a problem. But if you have two sites with a reasonably small WAN between them, you're going to get more shift in the bandwidth. The availability of bandwidth goes up and down a lot, triggers more events. So that's a huge influence. Next. Volume of calls, that's an easy one, right? If you do 10 calls, you get not much. You do 1 billion calls, you get a lot. So that's easy to come up with. Bandwidth, again, it's really about the amount of data that is created by these updates. If you're only doing a handful, small bandwidth. If you're doing a lot of bandwidth. Last one. And storage. So if you're doing anything but pumping this out to an SDN and a policy engine that's adjusting your network, if you're keeping this stuff, obviously, the more clients, the more volume, the more changes, the more storage you need. So all up and down, all of these are parameters for where you set that update interval. Data flow, this is really simple. I tried to simplify the model that Mike had down to something that just makes sense for this demo. So the client basically creates a message, forwards it off to a front end. There's a process in there that picks it up off the front end, drops it into the SDN, forwards it off the controller, and then something consumes it at the end. So it's a pretty simple data flow. Next. And this is an example. It's probably a really bad example. Looking at on the screens here, there's a lot of data. One of the things I also found is that the client even produces more data. So what comes out of SDN is really a subset of what is captured by the client. There's too many fields to even mention. It's actually quite a bit. But the really important stuff, the stuff you really need, comes out of SDN. So MOS scores and jitter and those kinds of things. So best practices. I guess if you look at this data in isolation, it's a really bad thing. It's like anything, you need to look at the environment. You need to look at what's going on around before you make a decision with data that you have. You can go off in a completely wrong direction without even knowing you're doing it, without really looking at things. And this is where I sort of came into it. What can you do with the data? SDN for me has always been something that was mystical and wonderful, and you can adjust networks with it. You can do really funky things. But I looked at it. I thought, okay, well, there's other things to do. You can do really, really cool things when you start to see real-time data coming out of calls. You can dashboard it. You can pretty much do anything. Just you can putting it in dashboards is kind of a simple thing, but you can also make real-time decisions on it. So for example, what if you were in a call and we saw quality dip, it dropped down below some threshold that we were told from SDN. I can then fire off an IM automatically. I can communicate to the user and say, hey, we know there's a problem with the call. So this is not after, not while you're in the call worrying about things. We can tell you. And in fact, even more fun, I think it's fun anyway, you can tell the person at the other end, right? So you're the one with the poor quality, but the person at the other end of the call, we know they're there, and in a lot of cases, we actually can see their availability because they're on link, Skype for Business, sorry. So we can tell them that your other party is having a bad experience. How cool is that? And all this comes out of SDN. You can do really, really cool things with it. So I'm going to do a bit of a demo in a minute, so I just want to set things up with a topology diagram here, just so you can understand what's going on. So really simply, some clients talking to Skype for Business. Some are coming in through an edge, so I'm on my notebook here, coming in through an edge, which is on a Wi-Fi device, purposely creating bad quality. If we did this session earlier in the week, I would have just connected to the normal Wi-Fi, but because everyone's left, I had to go down to that one. So that's sending to an SDN controller and being consumed by an application. In this case, it's one of our applications. And then we're connecting back to that application over the web. So if we can...
Where do you want?
Can you swap the...
Yes. You are 7, right?
7.
Okay. Oh, wait. Now we can go. Okay.
7. Okay. So this is the call that we had up earlier in the session. So we've got... essentially, I have a call from my cell phone down here, calling through Australia, so this server's actually in Australia, and coming back to this desktop via that Wi-Fi access point, which is why the quality is really bad. If you're in this call, if you were talking to me on this call, you would be complaining for sure. So what I'm going to do is drop this call. Another cool feature. Of course, this is the downside.
It was a 1.27. That's like a 1-star, dude.
Well, you know, this is another conversation, but ask me another time. So I'm just going to close that. I'm going to go back to my client. Well, Ken, what have you broken?
Can you imagine? Demo's gone awry? That never happens.
Come on, connect.
Come on.
Yeah.
You can do it.
No, drop that call. Sorry?
We're going to see 1,000 of them.
No, don't drop the call. I'm trying to connect to the conference.
Data. Nope.
It's only a conference. Did you drop it? Can you try and connect to that conference? Right, well, drag me in. See, we're on purpose trying to demonstrate a poor quality call, but it means all of the bandwidth is going through that Wi-Fi access point. I got the message. Come on, move. add Christian in.
I have accepted. I am muted. Hey, we have video. You're right, the talking head.
It looks like mine is connecting here, but it's going very slow.
Okay.
But so we have 2 participants, and Ken might just drag some more people in for us. So what I'm going to do is just go here and find this conference when it comes up.
Show up.
Slow.
You can do it.
Should have had 2 Wi-Fis.
You can do it.
One for calls.
You can do it. There it is.
It's coming.
Show up, please.
There we go. Right. So, what we should have here in a second when our Wi-Fi kicks into gear. Right. Okay, so 2 participants. Obviously, one of them is a non-Wave 16 client. One of them is a Wave 16 client, so we we should get in a second here data come up for the call. Unless so many people left that the quality is perfect now. Ken's coming in, so you can see a federated call. So all of this data here is actually coming from SDN at the moment. This is all filtering through our servers in Australia and coming back to this system over SDN.
I'm going to unmute the mic so that way we can capture some of that data too. But I'm going to turn the speaker off. There we go.
Yep. I definitely should have. Still, yeah. So you can see that was me, that connection that just connected and dropped off. It saw the call come in and couldn't do anything with it, so dropped me out. So we can see the calls coming from Microsoft, and the quality's just not here yet because of this slow connection. I made it too slow. So the concept is that because we get these in-call quality updates, we no longer have to wait for a call to finish to get real data about a conference or about any call, actually. I don't think that's going to help.
Let's bring it closer.
So when a call stands up, it completes to the conference server. The packets from the clients are sent through the normal interfaces, you know, SIP invites and things like that. They're picked up by SDN. We see the start of the call, so we can say, hey, there's a user on the call. Typically, what you get out of those invite packets isn't much. It's really, here's a call, here's a codex, you know, really simple stuff, rudimentary information to actually create a call. But still not there. But with in-call quality updates, what we're seeing live come out of the clients is in fact the full end of call packet. Pretty much everything that goes that you would see in the QoE databases is in that in-flight packet. So it means that we can see that over SDN. SDN picks that up, we get that packet, and we can visualize it when you're not on a slow connection, and display it to users. So we can take action, we can, you know, visualizing it is kind of a reasonably simple thing to do. But from that point, you can take action. So we can see on here and say, you know, IM users, or tell people different things going on with their quality while the conference is actually running. It's something that we've really not been able to do until Skype for Business, until these new clients came in and gave us that capability. It's something that is, I think it's really cool. And it's a shame we made it too bad. So with that, back to you, Christian.
Sure. And we'll switch back to me.
Camera one. Oh, yeah, demo. Demo's done. Why don't we get to some Q&A? I know someone had a question about Office 365. Yeah, it's funny. They're almost ready to say something. The answer is, well, I'm going to give my non-Microsoft employee answer, okay? The answer would be, it would be highly unusual, let's say, for you to deploy Office 365 with enterprise voice and express route, guarantee QoS markings into the cloud, and so on, and not be able to manage and monitor the data, okay? They're not ignoring that either. I just can't give you the answer yet, okay? In progress. Make sense? Cool.
That's a shared tenant answer rather than a dedicated answer.
Oh, did you say O365D? Oh, D. See me after. I have, see me after. We'll talk about that one right down here. I have some D customers. And yeah. Okay. Any others? More questions? More questions? And by the way, the questions, when they get hardcore, I'm still going to lean on these guys. So we might as well fire up all three mics. And I'm just going to handle the softballs, and they're going to handle the hard balls. How's that?
So you can see it finally. Maybe moving over here.
Yes. All right, so next question, sorry.
So conference calls. So will you be able to tell the data if they're going to a web app or how the foreign person is starting a meeting and where that? So if I have 10 people on a call, I'd be able to tell which one may be the one having the issue.
Yes. Yeah. So we can tell in conference calls who the user is, and you get all the device-specific and client-specific information associated with it in the messaging from the SDN. Yep. So the good thing is, I mean, as you guys know, audio and video works. You have source to destination, destination to source streams, and so we're able to identify explicitly which is the where does the problem reside. It's typically not both sides of the streams, right? So you have a lot of asymmetrical routing we find in a lot of networks. We'll go over here and then we'll come back to you.
Yeah, mic's on.
So I think someone asked this already, but I didn't quite understand the answer. Your monitoring products is leveraging the SDN northbound API or the northbound interface. So are you listening to controller messages? Are you communicating with the controller directly? Yes. What's your interface? Is it the LSM or is it the controller, or are you just in that stream listening?
Okay, so I'll repeat the question. Good question. For monitoring and diagnostics, are we getting information from the controller, or are we getting information from the LSM, or what are we getting it from? So, it's
Pause.
correct, right?
I think you said good question, didn't you?
I did. So the construct of the SDN interface for Skype for Business is the link dialog listener and the link SDN manager or Skype developed components. Third-party solutions like Nectar, we have the controller, so we receive the messages from the link SDN manager pool. We're an SDN controller. That's right. Mm-hmm. Wait, we were going to go back here and then we'll come to you. Yeah.
Yeah, similar question. If you don't have a network controller that's SDN
Well, so the question is, without an SDN controller, can you still get at the in-call information? And that answer would probably be no. I mean, maybe you can hack together an application that can consume that information, which I think probably a lot of you are capable of doing. But the Skype for Business team, they have a program and they have qualified SDN partners. So controllers that are qualified to consume the messaging, and then associated scenarios that they're able to light up.
Like in Dave's demo here, was there a controller?
Dave's
Yes.
platform would be the controller.
Oh, the software is the controller.
Yeah, we're consuming the
Yeah,
SDN.
yeah. The controller is kind of can be hardware, virtual, whatever. It's just whatever entity is receiving the SDN API information and then using that to perform some function, be it monitoring, we do diagnostics with it, remediation, things like that. Yes.
Shirt came at you.
Yeah.
So in an average deployment of say multiple sites, international, say you had like 6 front-end servers, like 3 pools spread across 3 completely different regions. How much hardware would you expect to introduce controllers to make that effective like SDN solution?
Not much. I mean, this isn't really heavyweight messaging. You know, you can define how you want to set that up, but that's going to be vendor specific. So for like Nectar, I mean, we'd have to talk through what your availability requirements are. We could probably do that with one controller, depending upon your user load. Because you don't really have latency issues associated with the messaging. It's not like it's media. You have, like if you have a super high loss network, then and you aren't receiving messages, that would be a problem. But other than that, yeah, I mean, it's not real heavyweight. It's not real.
So it wouldn't be silly to maybe have an SDN deployment for controllers in North America, and you're still feeding data from, say, APAC?
We've got that. That is a very common topology for what we're seeing. Yep.
I think he liked the question.
Dang good question. Yes, sir.
I mentioned this in the booth the other day. So can we use this not just for call quality, but also to monitor like our capacity, our bandwidth usage, and kind of use it to tweak our CAC policies and things like that?
It's John, right? Yeah. The only guy in this entire conference inquiring about call admission control. The guy is good that we've spoken with. So the question was, can you use information from the SDN API to kind of monitor CAC? So
Like Moldar, to help, tell us, okay, we should be doing, we should be adjusting our policies.
Yeah. So we've had this conversation with customers before where within the SDN API, you do get the actual number of packets, bandwidth kind of applied and used. So you could model that out and trend that over time to eventually leverage that in your CAC modeling, because for UC, you aren't doing per call, you're doing bandwidth limits. So it would be useful to have that. I'm not sure specific to that, that you couldn't just pull the data out of another tool that's pulling insight out of the QoE database, because that's more of a trending analysis over time thing, and the real time nature of SDN probably. I don't know.
It's not enough information, really.
Yeah, I don't know if
to
it
make a
lends
good
you
assessment.
a huge benefit.
It's more just call quality, basically.
Well, it's any type of messaging quality, but it's real time insight into the load and the usage on your network by your Skype users.
Okay, and someone, just so we could go back to the network team and try to sell this to them, this doesn't require any like network probes or anything.
No.
That's the
It
beautiful
depends
part
what
about
you
it.
want to do. Caveat it. It depends what you want to do and which partner you're using. If all you want is dashboarding and showing kind of insight into who's doing things on the network today, that's right. All you need is the controller capability. If you want to move into diagnostics and start trying to isolate where, hey, I see that we had a bad call event during this call, or we had a bunch of them, and you want to try to gain insight into where that happened, the information from the Skype client is still end-to-end information. So it's not going to tell you it was in this segment of the network within this location. It's just simply going to say, for those 2 users, on that session or in that conference or that side, that specific stream of that session was impaired. Yeah.
At that interval too.
At that interval, correct. Which is, aside from this gentleman who loves the log review, I think all of that correlation helps simplify it a little.
Just a quick comment. We have about 5 minutes left for Q&A, then we can do stuff afterwards, so we can take a handful more.
But
Yeah.
in one of your slides, you show it the trace route or something like similar to a trace route.
Yeah.
Just point to a specific.
Well, so actually that was something, that was a Nectar specific product and implementation, and we've got a capability. I know we aren't trying to go product specific, so I'm sorry. But we can route peer with the underlying topology for diagnostics. And so we associate the network path with the actual session path. So, but that's just what's possible with SDN, right? We can route peer, which is real-time awareness of what the tables are. We get real-time insight into the sessions that are happening. A session goes bad, we've got timestamps associated with that. Now we can go automate looking at the network and the interfaces to identify, that thing that happened was a cause of a queue overrun on this interface, on this router, in this path, in that location. SDN power, that's the power SDN. Yes, sir.
Christian, they're coming out with a dashboard for Microsoft releasing a dashboard out for the Skype for Business. Is that thing you can admit you can work through that?
No. Call quality dashboard is an after-call solution. It's essentially a improvement on the limitations of SSRS on top of monitoring server, and it's a better way to process the data and deliver more of it quicker and much better looking.
Yes, sir.
So, in an environment where you already have a controller running, does these types of products stand side by side with that controller, or does this product have to be the controller for the environment? So I guess what I'm trying to ask is, so I observe via SDN that there is an issue that I need to address. Today I have a controller that's already listening, and maybe there's some custom objects like policies that I've created and it's working.
Right.
Would I move this in to be the controller, or would it stand side by side?
So I'm not going to answer that question directly because I don't really know all the details, but let me just surface a scenario that we didn't talk about. So the LSM basically just broadcasts out information, and you configure a submit URI for it. So that's basically the web interface that you're going to be pointing all of this data to. So what we've seen in some deployments is nobody has complete visibility across every different vendor's elements and capabilities. So in the construct of the LSM, you could then have multiple submit URIs that receive the same data. So the scenario that we've actually worked with this in is you've got a Wi-Fi controller from Cisco or Aruba or whatever. They need the information, and then you also send that exact same information to the SDN controller, or to another controller.
Right. So so a concept could be that this would be your UC controller to do QoSing manipulations, etc.
That's right.
Okay.
That's right.
Yeah.
Yep. Did you give him a T-shirt? Did you already get a T-shirt? Right.
You can really have any number of consumers.
I'll give you my shoes.
So you can have any number of consumers listening to SDN.
Yeah.
I mean, it could be hundreds.
Right.
Obviously, you'd run into scalability issues, but you could theoretically have as many as you want.
So legally, I would say one controller to rule them all, but what we're saying, or what we're establishing here is a functional controller based on UC, wireless, storage, and not necessarily.
I think that's a correct assessment of the state that we're in currently with this networking transformation. Yep. Yep.
Any other questions? We good? Thank you very much, folks. This is the last session you have to deal with today. I'm sure you could probably try doing the 12 something or whatever, but I'm sure most of you are trying to get to your flights. Thank you.
Thank you.
Thank you.
Nice work, man.